Okay, as you may know, actually, I'm Dariush Salami. I have to give a brief background about myself. I've graduated in bachelor from Shahid Beheshti University of Tehran in computer engineering software, and master from American University of Technology, again in Tehran. And currently, I'm a PhD student at Aalto University. And here is my research topic, gesture recognition using radio frequency sensing, and my professor is Stefan Zig. Actually, my first research question is about how we can use millimeter waves to kind of do gesture recognition. It has lots of use case in e-health, human-robot interaction, and autonomous driving. Why it's important? Because first, it's a privacy-preserving approach. Instead of recording every single detail in the environment, we can use actually millimeter waves to record the information that we need. And second, it's cheap. So to conduct this research, I've used IWR1443 device, which actually is working in the frequency range from 76 to 81 gigahertz. And we get out of this device a moving point cloud, which is highly sparse. In each frame, we have only 4 or 5 data points, which is nothing in comparison to devices like Microsoft Kinect. To do so, we have collected 2 sets of data sets. The first version is in a single environment. We designed 11 gestures, and we asked 5 different participants to do each of these gestures for 20 times. So we have 1,100 samples. We use this data set to develop our model. And in the second version, which is the one that we are going to publish on Zenodo or somewhere else, we have more than 40 participants, 21 gestures, 2 environments. The first one is open space, and the second one is work environment, like office. And we have 8,000 samples. This is the first data set which this amount of sparsity, in the literature, because all the data sets available, like NV gesture or ego gestures, are highly actually dense. So we developed our first model, which named Point Gest, and we are going to submit it to Mobicom 2020 in mid-March. So although this model is for dense point, highly sparse point clouds with a subtle, change in the architecture, we applied it on dense point clouds, and it outperformed all the other state-of-the-art algorithms in dense point cloud also. So we have the results in that paper. As a topic that I want to follow, actually, I want to go a bit toward communication. So Peter Popovsky, my second man in Aalborg, suggested that maybe we can use same infrastructure to communicate and sense at the same time. So we are trying to use 5G NR, especially the flexible numerology in 5G NR, okay, in 5G NR to sense and communicate at the same time. We think that it's a perfect environment for applying reinforcement learning-based algorithms. Why? Because we have a reward-based environment, and the reward is the accuracy of the sensing and also the spectral efficiency of the communicating. So in what follows, we are trying to dig into this problem and find some way to do sensing and communicating at the same time in 5G infrastructure. To do so, we need either 5G infrastructure, which already exists in Aalto University, or a simulation environment. And that's it.